11:45, so we're ready for our lunch panel. We will be doing a panel on AI and the future of workforce. And stay tuned afterwards, we do have a giveaway. So it looks like our panelists are on. If you guys want to go ahead and unmute yourselves, turn on your cameras. Hi, Chris.
Hello.
Oops. Hi, Nada, you are upside down.
Hello. Yeah, I noticed that.
And Fuad has a very cool background. Okay, so again, my name's Casey. I'm working at Soft, and I'll be moderating this panel, but I'll let you all introduce yourself. Fuad, if you want to go first.
Okay, so guys, how are you? I'm Fuad Hassan, and I'm a PhD student in LSU. I am doing my research in power system optimization. Today's discussion is all about the application of artificial intelligence, or if I say that machine learning and more general, deep learning application of them in different sectors. And particularly today, I will discuss about how I am applying deep learning or machine learning in my research work, and what is the gap between the academia and industry, and what we can do to make it more available for common people, and so that people from all backgrounds can work on machine learning and deep learning. That's it. And we have some questions, and we have prepared some answers for that. I think we'll discuss.
Perfect. Nada, do you want to introduce yourself?
Yeah, sure. First of all, I'm really sorry about the camera. It's upside down. I will try to fix it later. So my name is Nada Bailey. I am a master's student in computer science at University of Louisville. I am actually originally from Tunisia, which is a small country in North Africa. So I have my engineering degree from Tunisia, and I came to the US exactly 1 year ago to pursue my master's degree and later my PhD, hopefully. So despite this long academic path, I do not really see myself having an academic career after. I'm still more interested in industry and would like to combine academic strength with industrial experience.
Perfect. We're glad to have you. I think we're all trying to get through our own camera difficulties. My teeth have never been whiter, so we all have to, but glad to have you. And Chris, introduce yourself.
Yeah, my name is Chris Martin. I'm an assistant professor of mechanical engineering at Penn State. So my background, my industry life was actually, so I'm a thermal fluids researcher. So thermal fluids control is my expertise. I am not an expert in AI. So I am more on the AI is something happening to me. It's something happening around me, and it's something affecting my industries. My industry experience was as a plasma torch design engineer for, so I was an R&D engineer for ESAB welding and cutting. So we were in the manufacturing sector, both as practitioners of manufacturing. So we manufactured equipment. This ranged from small equipment like handheld systems, all the way up to giant, huge gantries for cutting plate, shipbuilding, that sort of thing. So we had this whole range of size and type of equipment under one roof. And so we were both practitioners of manufacturing, but we also made manufacturing equipment, which put us in an interesting position to have to reflect on manufacturing on both sides of that.
Perfect. Okay, so how the panel work, I know we've discussed this before, but for the audience, I will pose a question to you guys, and then I'll direct the first person to answer. And then if you guys want to piggyback on their response, or if you just agree with what they've said and you have nothing to add, that is okay too. And then for the audience, we also will be answering any questions that you all have. So again, these are PhD students, and Chris is an assistant professor, so it is a little more geared towards higher education and AI education. So if you guys have any questions, you can add those to the chat. Okay, so the first question, I have a bunch of boxes open. Okay, how do you see AI helping us get back to school safely? And I will have Chris answer that one first.
Well, right now, our plan is still evolving. Is I think the best thing I would say. But right now, I'm not aware that we're really deploying AI to help us get back to school safely. I think this question could probably be best answered aspirationally. So how could it be getting us back to school safely? I think certainly there are all sorts of opportunities to do rapid diagnosis, right, based on symptoms. How do people present? I know it looked like the sale of thermal imaging went through the roof as soon as COVID-19 hit. I think, and I see this in my own fields as well, that the problem frequently isn't in the availability of sensors to detect a problem. The frequently we can have a flood of information coming in about a manufacturing system, or for example, say people can enter a new building, students coming into class, but how do we make intelligent choices with that flood of information? How do we correctly and reliably diagnose? That's where I think the promise of AI lies. From my view, we're not really utilizing that right now. Like that's not in place with us, but I think it could be.
Awesome. Nana, do you have any answers for these?
Sure, yeah. So how I see AI helping us get back to school safely, I would say by giving us the privilege of having the possibility to go 100% online. I mean, I don't think this was feasible a few years ago. So now we can completely be independent of the physical walls and switch to digital walls, if I may say, while still ensuring even a better learning experience. I mean, now with AI, you can learn while being anywhere in the world. You don't even have to speak the same language as the teacher or the professor, since, for example, there are real-time AI translators. So yeah, that's my perspective.
Yeah, that's a great response. And Fuad?
Hey, so the question is that how do we see AI helping to get back to our school safely? So first of all, I will say that every day we are seeing different kinds of news sources, and we are seeing different kinds of prediction that this may be the COVID spread the next month, next semester, next year, whatever. So what can be the possible COVID spread in the following month? And I think AI is all about prediction, and decision makers are using machine learning or deep learning to get these kinds of prediction. And I think based on this prediction, what we can do for our next semester, this is helping us. And this is one application of AI, how it is helping us to get back to safely.
Perfect. And those were all three very varied responses. So we had like thermal imaging, remote work, and ML algorithms. So great.
Yes.
Next question.
Yeah, that's it.
Let's see. Okay, how are you personally working with AI technology within your university? And Fuad, we'll start with you.
Okay, so first of all, artificial intelligence and in more specific sense, deep learning is a part of my research. I am working with power system optimization, and if I explain in general terms that this power system optimization or these numerical problems are very hard to solve, and they require extensive computational equipment, and they require each time to solve these problems. So what we are doing actually, we are trying to predict the partial result of this problem before solving the original problem. When we have some predicted result of the problem, like power system problems, and then we solve it is in the computer with the predicted result, and this way we are gaining some time advantage. We are speeding up the process to solve this problem, and in this way we are applying machine learning and deep learning in power system to solve our daily problems. I think it will be very helpful in the near future when it will be deployed in the industry. That's it.
Great. And Nada, how are you using AI technology within your university?
So I work at the Multimedia Research Lab at University of Louisville. So my main field of research concerns computer vision, digital image processing, and in general, applying deep learning techniques to analyze and better understand the visual world. So for the past year that I spent here doing research, I've worked on several projects. My first project was about building a system that analyzes and summarizes traffic surveillance footage. So the goal was to recognize the make, the model, and the manufacturer year of vehicles. The project mainly served a security purpose by automatically and accurately identifying, for example, a suspicious vehicle, or maybe identify a vehicle based on certain descriptions. I have also been working on automatic target recognition, which consists in identifying moving targets, given infrared images, which are images obtained from sensors. And also another project I am currently working on concerns the current pandemic. We want to build a social distancing detection tool that detects whether people are keeping a safe distance from each other by analyzing real-time video streams from cameras. Yes, for the past year, this is what I've been working on.
Wow, that's awesome. And it's cool that you can apply it to relevant.
Yes.
So.
Yes.
All right, Chris?
So we just kicked off a project, and I think you'll hear more about it when JR speaks this afternoon. So we just kicked off a project with Vsoft focused around quality control inspection and manufacturing, specifically looking visually at pipe threads. So in this is actually a really interesting example where AI is highly appropriate, because I like to tell a story that an experienced machinist can just glance at a pipe thread, especially if the machinist has been making pipe threads for years. And there's the way a pipe thread looks. You just learn to recognize it over time. And that's exactly the kind of thing that's almost impossible to standardize in a quality control inspection environment, right? How do you got to reduce it to specific dimensions you can actually put a gauge on, right? But if you could make it so that you just needed to put a camera on it and allow and have an algorithm or a model look at that image, and now you could take that experience and standardize it across an entire manufacturing line, right? You could take that years of experience, right, implement it in an algorithm and standardize it. This is an attractive option, right? And recognize flaws in pipe threads. I would say, so that's how we specifically are working on it. Now, there's a much broader thrust to apply AI in manufacturing, not just for quality control, but I've heard already mentions of maintenance so making prognostics about maintenance, right? So that's a predictive maintenance is a big topic, right? Not just in manufacturing, but power systems all over the place. And so that, there's a much broader community within manufacturing of people interested in implementing AI as well, in addition to just what we're working on.
Perfect. Okay, what areas or applications of AI do you want to make a difference in, and why? And Nada, you can start us off.
I am personally very interested in the area of autonomous driving. I have been working on certain aspects of this field, such as object localization and detection, but I haven't really worked on the core problem yet. So I'm actually very optimistic that this new technology will be a major upgrade for today's transport industry. Autonomous cars are actually safer. There would be fewer road accidents. There would also be a major impact on the global economy by reducing the fuel consumption. Because autonomous cars, they are basically computers, so they work by optimizing their functioning to be efficient. So yeah, that's, I personally would like to conduct my future research around autonomous cars.
Awesome. And Fuad?
Okay, thank you. The question is that what areas or application of AI do I want to make a difference in, and why? First of all, that as I already said, I am applying machine learning and deep learning in my PhD research work. But the problem is that in our case, the algorithms we are developing, it is not still deployed in the industrially, because power system operations are very crucial, and some mistakes, a very simple mistake can incur huge economic loss. So as the algorithm we are developing, and the AI is all about prediction, and it is not 100% correct. No prediction is 100% correct, okay? So this little amount, even less than 1% of misprediction, can be very sensitive for power system. And we can say this is Achilles heel, like something, if the industry people, they say that we will not accept this 1% error. Okay, done, we are done. What I am trying to do, that actually trying some more robust algorithms to apply in power system, which are very high, which are highly accurate, and we are also trying to develop some algorithm which can take care of this 1% misprediction after the after the prediction from the AI. This is what actually we are doing right now, and in this way we want to change power system that works.
Perfect. And Chris.
Well, so I think the buzz term in manufacturing is Industry 4.0, right? So that's the phrase that's driving a lot of activity in modernizing manufacturing, and what it is for those of you who haven't been immersed in that buzzword, what it basically means is it acknowledges that we've gotten to a point in manufacturing where we're very good at automating repetitive tasks, right? So robotic welders, got it. CNC manufacturing with mills and lathes, got it, right? We've been doing that for a long time now. And we've even gotten to the point where we're very good at outfitting those pieces of hardware with sensors. They give us a stream of information to predict, when is my tool going to wear, when is my tool going to break, when do I have manufacturing problems with an individual machine. That we've gotten better and better and better over time at getting feedback from these systems to understand how they're doing and to take corrective action. Where we aren't yet, and where we are very much trying to go, is doing more with that information and being more planful at how an entire facility or how an entire organization functions. And this is where AI is playing a major role. And so my expertise is not directly in AI. My expertise is where the AI meets the machine, right? Is the development of sensing and control systems and algorithms. And so as we try to get more and more signals out of the system and give more and more levers for an algorithm to pull, right? So more and more knobs to turn to get systems to be optimized. One of the big questions is, how can we reliably, robustly, and securely get that information to make big decisions? So in a really specific, let's get concrete with it, right? Really specific example, someone clicks buy on an Amazon webpage, and minutes later, the idea is, in the ideal lean manufacturing world, a robotic part picker goes and gets all the parts, takes them to their workstations, machines spool up, and parts start going through the assembly line. And the finished manufactured part that was nothing but raw materials before that day began ships by the end of the day, right? So that's kind of the dream, is you get to this beautifully streamlined system, but of course tons of problems come up, and security is way up there. Mm-hmm. It's that networked, right? If someone's in your network, you've got a problem, right? So yeah, so there are lots of topics that come up.
Great. Okay, I see the question that's coming up. Let me check our Q&A, because I know we have at least 4 in here. I like this one because I know, Nada, you talked about the pandemic already. So how adaptive can these AI technologies be when and if a future pandemic happens? So how adaptive can AI be?
Actually, the system we have been working on and still working on, the idea behind it is to make it adaptive. So we will be applying, I mean, the idea was inspired from the pandemic to detect the social distancing, whether it is respected or not, but eventually we were thinking about applying it everywhere in the workspace to make sure that the employees and the workers, they are safe, whether we can actually use that system to optimize the position of the machines within the workspace, to optimize the distances walked by the employees. So yeah, it will be directly applied, hopefully, to serve the social distancing, but we are definitely thinking about making it generic and able to serve other purposes. So, I mean, such systems, they are based on milestones, such as, for example, object detection. We need to detect the persons within the video streams. And then having these detections, we can apply any other tools on those results.
Perfect. Did anyone else want to take it from there? How adaptive can these AI technologies be if a future pandemic hits? Okay.
Yep, good question.
No worries. We have one more on that's the official question. So let me pull that one up real quick. What gaps of learning AI tech do you see in our current educational systems? And Chris, since you let it slide, I'll let you start.
Sure, no problem. I actually happy to jump into this one. I think we're at a really interesting place with AI right now and machine learning in general. I'm reminded that when computer science was first invented, right, as a field, it originally lived within mathematics because the mathematicians were primarily the people working on the problems, right? It really hadn't crossed over into engineering yet, and like the engineers were all working with hydraulics and steam. So I feel like I suspect we're at a similar place right now where AI and machine learning seems to live, and it's still growing into its own discipline, right? And I'm really interested to see how universities react to the growth of this new intellectual domain. I think the spawning of independent programs and expertise in machine learning are probable, and I see that going forward, certainly. But I also suspect, and again, please keep in mind, I'm not an expert in AI, but I do teach for a living, and I see a lot of parallels when we talk about machine pedagogy and human pedagogy, and the idea that there are some basic ideas that are consistent between those two. That some of the lessons we take from teaching humans, that is, you need to give students consistent, clear expectations. You need to make sure that you don't give confusing and contradictory directives to students. These same trends hold true with AI, that if you give contradictory directives, you get mixed up results, right? You can confuse the algorithm. So these are lessons that, interestingly enough, a humanist approach, ironically, right, seems to be valid here. Like there seems to be something to learn there. So I wonder what intellectual framework will grow around AI within universities moving forward. I don't know. It's difficult for me to see that, but what I do see is it's still evolving.
Great answer. Okay, well, Fawad, answer. What gaps do you see in AI tech and learning in our current educational systems?
Okay, thank you. So for me, I am a new student in this machine learning field. I'm a new student. I'm working for 2 years. I mean, not in this field and trying to apply. So what I feel that the easier representation of the AI algorithms will be very helpful. When I search over the internet to solve some problem, I see some explanation of some algorithms. They are very mathematical intensive, and that is not so easy for me to understand all those mathematics. So sometimes I feel that we need some more which can be easily understandable by people like us who are not actually from the computer science background. So we need more trained teaching staff who can clearly explain those things and those algorithms to us. I think that will be very helpful.
Perfect. And Nada?
So my academic background is mostly influenced by my country of origin, since I have been a student in the US only for 1 year. So I have quite a lot to discuss and criticize about the AI learning in the Tunisian educational system. But since we're talking about the American educational system, from the year I have spent here taking computer science classes, I can say that I do not think that the offered AI learning is as advanced and up-to-date as I thought it would be in an American university. But to start with the positive side, there are AI classes, so trust me, that's already a plus compared to other educational systems. But still, all the AI-related classes I personally took, they address basic knowledge that do not keep up with the rapid evolution of AI in the world. I mean, it is important to, of course, to address the basics, like for instance, the concept of neural networks and machine learning that date from the 1950s. But what is lacking are the innovative concepts that came after, the newest learning techniques, the newest applications of AI. Providing such knowledge would enable students to keep up with the rapid progress of AI and eventually be able to innovate themselves and come up with new ideas. Fortunately for me, I was able and still trying to fill this gap through my work as a research assistant. By working on real-world projects, I was forced, like literally forced to go beyond the classroom walls and learn by myself and be updated with the AI novelties. And I actually believe all students should do the same and never settle for what is being delivered inside the class, because that gap will appear even worse and more harmful when you try to go to industry and work on real-world projects that require efficient solutions, and that won't happen unless you know way beyond the basics.
Great answer. I feel like there would be a lot of self-learning when you're trying to study AI because it's new every single day, basically.
Yes.
All right. I think we answered this one already. Similar question. So let me go into the audience question and answers and see what we have. All right, let me move something around. Okay. How does the panel see the AI innovation helping with online learning, both on campus or corporate digital learning initiatives from students and professor perspectives? Did you get that? Can you all see this question in the Q&A?
Yes, I think so.
So online learning and then corporate digital learning. How can AI help?
Well, I'm aware of cases from quite some time ago. Actually, I don't remember how old these were, but I think a number of institutions have tried using machine learning-based instructional modules where obviously a lot of structure is needed for this, where but an algorithm can start to make active decisions about how difficult a question to pose to the learner, to the student, based on their prior answers, and can start to adapt in what new materials. So basically an algorithm would be given a bank of materials and questions and problems that could be presented to a student, and then would select a path through those materials based on how the student's doing, right? So basically one of the big advantages there is it's really difficult as an instructor in a class with even as few as 16 students to be that adaptive to individual difficulties, right? You really have to walk around and start interrogating every student, like, okay, what's hanging you up, and sort of get a feel for where they are. Like, okay, we'll try this. You know, that level of personalized lesson adaptation becomes much more pragmatic and much more economical if you can reduce it to an algorithm. Now, the original curation of those materials still seems to be best done by a human, as far as I'm aware. But I think that's a really interesting application, and it would mate very well with online learning, right? That's the kind of thing that you could do really economically with a web-based delivery platform for education. Wouldn't it be great if I had that right now as we try to figure out how we're moving into the fall semester?
Right, exactly. Great answer. And Nada, I think you were going to answer too?
Yeah. How can we use AI for educational purposes? I think it would be best used to take advantage of the real-time data, because when you say AI, deep learning, machine learning, you say data, that's it. That's the most important component of the whole field. It's data. If we don't have data, we cannot apply any of the AI algorithms. So we might take advantage of the real-time data, real-time feedback, and we can use that to analyze students' performance and have better assessment tools than simple testing and scoring. So for me, I think that's the most, I would say, revolutionary change, is that we will be changing the way we assess students, and we will be having a look at an individual look at each student. It can also be used to create individualized learning programs that adapt to the peculiar student needs, to adapt to his or her own pace. We can also use it to change the entire college admission process, make the college decisions more personalized, take into consideration more relevant personal factors rather than just test scores. And the entire process could also be entirely automated, so that would take less time and less work. So yeah, that's how I see it.
Admissions, that's a good use case. I
Yeah.
like that. And Fawad, did you want to answer this one too?
Okay, yes. So in case of academic institution, I see that in my university, different departments are offering various machine learning and deep learning courses, and students from different non-technical backgrounds like psychology, and even from like CA student literature, they are attending to machine learning courses. Last year, I attended a course on deep learning, and I had a friend from literature department. That was amazing. So this is a very good indication that people are really going into machine learning or AI technology. And the application of the AI in academic research is far more visible than the teaching curriculum. When we search different academic articles, we see that everyone is trying to apply various AI tools like machine learning tools in the research. They are either there from health sector, energy sector, or defense sector. Everyone is rushing to artificial intelligence to apply and to improve their services. And in case of, especially if we specifically focus in academic institution, I think AI can best perform to analyze the student performance. We can, by analyzing the performance and the data of the students, we can see that which student is need more focus from the teachers, and we can take better care of those kinds of students who are weak. And that can be a very good application of AI in academic institution, I think.
Can I jump in and actually add a little bit more to that too? Yeah, because I agree. I think that's all quite correct. I can even name some very specific examples of where that could be more better applied. I've seen research and I've seen work done to develop grading schemes. For example, project work has for years now been has become an important part of engineering pedagogy. And so a lot of engineering programs are instituting capstone design projects and the curricula. And there's always a huge problem of how do you grade those?
Exactly.
and it is a big problem. And there are some interesting techniques out there. And in a lot of those, they issue questionnaires to the individual participants in the group, right? And they'll be asked to rate each other. And what researchers showed in those studies was there were all sorts of fascinating patterns that emerged in how students graded each other, right? So they would just be asked, what grade do you think you deserve? What grade do you think your colleagues deserve? And fascinating patterns emerged. You started to see styles of group dynamics emerge where, for example, let's say 2 group members rated each other very highly and then the other 2 very lowly, right? So clearly 2 group members didn't like each other and formed factions, right? So you see patterns like that begin to emerge. Other times you see a bunch of group members all rate each other very highly and one person very lowly, right? This is a whole new group dynamic. The interesting thing was that the research didn't say, here's the grade you should give those people. It wasn't about, the purpose of the grading wasn't to try to figure out what letter does the teacher put on the page. The purpose of the research was to develop a model for understanding the problem in this group dynamic. Now, what do you do with that information? That's a whole separate pedagogical question. But this is the kind of thing that AIs actually could start to pick up on in these sorts of programs. And there's one other thing I'd say is one thing that universities have historically been very bad at, because we're not set up to do it, is some are better at it than others, is track individual students through their entire experience in college, even if they cross departments, even if they, whatever their educational experience is, how are you doing? What are your problems? How can we best guide you to success? And learning algorithms are in a position, I remember 5 years ago, we had a student try this and it didn't end well. That doesn't mean it won't for you, but you might want to be aware of that. You know, that links back to the data element. Like, wait a minute, we run experiments every time we graduate a student. That's a new data point. That's a new experiment. Wouldn't it be interesting if we could find ways, while respecting privacy, to connect, to benefit from that data? Now, privacy is a big issue, but it's a whole separate conversation.
Okay, great. And what I've learned is data is probably the most important part of AI. So thank you all so much for your time. Let me give you a round of applause. Thank you all so much, Claude, Anna, and Chris. If you guys have any other further questions in the audience, we will compile any questions that we didn't get answered, and that'll be either a blog post on the AIIC site or a follow-up email. So we'll definitely have any more questions answered by these experts in the panel here. So thank you all, everyone. You're welcome to mute yourself, and you can stick around or you're free to go. Thank you.
Thank you.
See you guys. Welcome.